Density of measurements. Scientific method. We will soon be ready for the Sensys scanning of 1,000 acres in Lee County, Iowa, during the first 2 weeks of November 2020. There are 8 professionals and computer specialists who will be involved in the collection and analysis of billions of points of data. These scientific results are greatly dependent on our systematic approach to ask and answer questions. The framework of our inquiry is the measuring and recording of observations. Here are the questions that will direct our research. 1. Observe. Make observations that are measurable and recordable as data points. 2. Question. Ask questions about the observations and the data points. 3. Hypothesize. Form a hypothesis, statements that attempt to explain observations and data points. Make some predictions based on an idea. Look for patterns of human habitation and living. 4. Test. Test the hypothesis using a reproducible experiment. 5. Conclude. Analyze the results and conclusions, thereby accepting or rejecting the hypothesis. 6. Redo. Reproduce the experiment enough to ensure no inconsistency with observations, data points, and theories. An essential step in this process is the collection of measurable data. Let's put our attention on how the Sensys MXV3 machine measures and stores data. One observation has 3 quantifiable data points. The first data point is the magnetic forces from materials that connect to ancient human activities that are in the ground. These forces are calculated on the surface but come from about 5 feet in the ground. The success of our search depends entirely upon the science that produces exact measurements. Of all the subterranean archaeological artifacts that Sensys can quickly identify, fire pits are among the easiest. The heat of ancient fires altered the magnetic properties of soils and rocks. The Sensys fluxgate tube can measure 1/1000th of a Tesla, 1 nanotesla. The Earth's magnetic field that moves the needle of a Boy Scout's compass is 50,000 nanoteslas. So, the Sensys machine is about 1/50,000th as sensitive as a compass needle. This fineness of measurement makes it possible to locate fire pits, post holes, roads, and walls that are thousands of years old. There are 16 magnetic readings per inch too. Let's figure out the density of data points per acre. Question: how many square inches in a square foot? Answer: 144. Question: how many Sensys data points in a square foot? Answer: 144 square inches x 16 data points equals 2,304. Question: how many Sensys data points in an acre of land? Answer: 2,304 by 43,650 square feet equals 100,569,600 data points per acre. Each magnetic data reading is significant, with 2 GPS coordinates that are +/0.25 inches accurate. That means that for each acre of scanned land, there will be 100 million data points. We expect to scan as many as 100 acres per day. That would mean collecting 10,000 million or 10 billion data points per day. The Sensys Magneto MXV3 is a large area magnetometer survey system. It has 16 fluxgate gradiometers on a trailer having a width of 12.5 feet. The 16 fluxgate tubes can make thousands of accurate magnetic measurements per second. Each measurement is fixed to a GPS rover station that is on the cart, that connects to a GPS base station in the field, and that connects to as many as 16 satellites in space. All data points are fixed to GPS coordinates that are within tolerances of ±1/4 of an inch too. The density of these measurements is beyond the expectation of any scientist or engineer from the last generation, an example of how far modern computer systems allow us to go in our search for the activities of ancient people.